Hello, my name is Sark Pasula, and this is my Physics 2211 Lab 1 constant velocity. So, introduction. So, what does constant velocity indicate? Constant velocity indicates that the net forces acting on the car are equal to zero. Therefore, the velocity will not change as no acceleration will occur. Newton's first law states that an object in motion stays in motion, which will be shown throughout this lab. So, the two objects that are used in person are a cart and track. So, a cart is essentially the system, and the track is used to keep friction at a minimum. So then Tracker Online and GlowScript are the two online tools that are used to provide experimental data and a computational model. Computational model is from GlowScript, while experimental data is from Tracker. So what is the purpose of this lab? The purpose is to compare the constant velocity of an object moving in the real world using Tracker and then comparing it to the computational model found using GlowScript. So what to expect? The findings of this lab will indicate that an object in motion stays in motion and maintains a constant velocity when no outside forces act upon it, which is shown through the comparison later. The kinematics used are these two equations where one is the update on velocity, where the other one is the update on position. The position one is also used to calculate the average velocity in the computational model. So there are three models being used throughout this entire data, which are diagrams, the tracker data, and then the GlowScript model. So the diagrams are used for system and surrounding models, while GlowScript and tracker are used to compare computational and real-life data. So here are the initial system and surroundings where my hand is acting upon the system and there's normal force and gravitational force. Now both friction and air resistance are considered to be non-existent in this system. And then normal force and gravitational force cancel each other out as they are in opposite directions with the same magnitude. So after my hand pushes the cart, it goes into motion and my hand is no longer a force acting upon the cart. And now it is just a normal force and gravitational force which cancel each other out. Now, Tracker Online. So, Tracker Online is what is used to get the experimental data as the cart moves a couple, let's say, centimeters. I click a button to track how much it moved in every couple seconds. Now, I got around 60 points of data, which creates this graph on the right. And you can see there are a couple of discrepancies which will be discussed in the next slide. So, discrepancies. So, the main discrepancies are human error since I am manually tracking this cart, friction, and there's also friction and wind resistance. So outside of these three um, discrepancies, there are a couple more, but these are the main ones that can cause a change in this data. So the initial velocity was calculated using the following, which is change in what's it called? The final position is equal to initial position plus velocity average times change in time, which eventually results in velocity average is equal to change in position over change in time, and resulting in our velocity that is used in our computational data. So here in our computational data, we changed the velocity to be the one that we found earlier, and then we changed the time to be the time of the video and the tracker, which is 3.03 seconds. And then we changed the velocity to indicate that if there was acceleration present, the velocity would change, but it will not change because velocity is constant. And then we update position based on velocity. Now, this is what results from that code, which is a straight slanted line for position time indicating constant velocity, and then a horizontal velocity time graph, which once again indicates constant velocity. Now, when we compare the two data, the one on the left is the computational model, and the one on the right is the data tracked by me. As you can see, that there is a couple of discrepancies here and here, which shows that there is human error present, and there's also possible friction and air resistance, which causes small differences between these two models. But overall, the data is similar, and which is similar, which indicates that the constant velocity is present. So what if? So what would happen if the axis were flipped? The magnitude of the velocities would remain the same, but the direction would be flipped. So now since the direction of the cart is flipped, it means the cart is moving the opposite direction, making it negative. So the main change is that the direction the cart moves is negative. So now what does it mean when, so essentially, is it justifiable to say that the net force is zero? It is not justifiable as both air resistance and friction are present in their surroundings. Therefore, they apply some kind of force onto the system, even if it is minimal. Therefore, the net force will not be zero. You can see there are a couple deviances between the computational real world data which support this statement. Thank you for listening.